You're welcome, our dear viewers, to today's lesson. In today's lesson, we are still about the topic. We are still on the topic of mole concept, but we are mainly focusing on the molecular formula and the empirical formula. So, what is an empirical formula? An empirical formula is the simplest formula of a compound, and a molecular formula is the full formula before simplifying to get an empirical formula. So we have a number here that states a compound X of carbon 40%, hydrogen 6.7%, and the rest being oxygen. If the relative molecular mass is 60, determine the molecular formula. What you need to know is, before getting the molecular formula, most of the times you have to first get the empirical formula. So, how do we get an empirical formula? We have steps that we follow in finding an empirical formula, whereby step 1 states note down the elements in that particular compound. Here we have carbon, which is C, a symbol, hydrogen, and oxygen. Step number 1, writing them down. Step number 2, writing down the composition. The composition can either be mass or percentage. In this case, they give us percentage as the composition. Carbon, which is 40%, hydrogen being 6.7%. They have not given us oxygen. So for this case, how do we find oxygen? We shall find oxygen by, we know that the percentage totals to 100, so that will be 100 minus 40 plus 6.7%. This will be 100 minus 46.7%, giving us 53.3%. So oxygen is 53.3. Step number 2 is done as well. Step number 3, divide by the relative atomic mass to get the moles. Relative atomic mass of carbon is 12, hydrogen is 1, and oxygen is 16. Here we are getting the moles. So 40 divided by 12, we get 3.3. Here we get 6.7. Here we get 3.3. Step number 4, divide by the smallest number in the moles that you've got to get the mole ratio. So the smallest number is 3.3. So you divide by 3.3 throughout. You get 1. Here you get 2. Here you get 1. This is signifying that the empirical formula C, 1 atom, then hydrogen, 2 atoms, and oxygen, 1 atom as well. So this is the empirical formula. So if the question says find the empirical formula, you will stop here and you will state that the empirical formula of compound X is as we've got here. So, but For the case that they told us to find the molecular formula, we have to continue until we get the molecular formula of compound X. So how do you find the molecular formula? Remember, molecular formula, before getting the empirical formula, they divide to simplify. So what we do, we let a number n to signify that this is a number that was used to divide throughout to get the empirical formula. So if we find the mass of that, it will have to equate to the mass that was given in the question, which is 60. The relative molecular mass of the compound is 60. So we have to equate it to 60. Then we find the mass of the compound. So how do you find the mass of the compound? Remember, this n will have to come inside to multiply by the atoms of the elements so as to get the mass. So this one atom of carbon times n, that will be n atoms, times the mass of carbon, which is 12, then plus hydrogen, which is 2 atoms, n times 2, you get 2n atoms, whereby 2n times 1, whereby 1 is the mass of hydrogen. N atoms of oxygen, because there is 1, n times 1, we get n times 16, which is the mass of oxygen, according to 60. That will be 12n plus 2n plus 16n, still equating to 60. 12 plus 2 plus 16, we get 30n. Divide by 30, divide by 30. N will equal to 2. So we've got our n. So that will be CH2O, whereby we've got the n as 2. So these two will come and multiply inside, whereby you get C2H, 2 times 2 we get 4, and O, which is oxygen, 1 times 2 we get O2. And this will be our molecular formula of compound X. So in another number, as we are going to see, where they say an oxide of iron 70%, 70% iron, determine the empirical formula of the compound. So what we have to do first is getting the percentage of oxygen. Minus 70%, shall get 30%. So step number 1, we said we state down the elements in the compound, then the composition, and then the moles by dividing the composition by the mass, the relative atomic mass. So here we get 70 divided by 56, get 1.25, and 30 divided by 16, get 1.875. These are the moles. Then you get the mole ratio by dividing by the smallest number. Here you shall get 1. There you get 1.5. So here is the main emphasis. One might say, what if I divide here and get a point? See that we've got a point here, which is 1.5, and it can be used in the formula. So what do? We get a number that we can multiply on both sides and get the whole numbers. And for this case, the number is 2. Here I shall get 2, and here I shall get 3. You see that this number has helped us remove the point from the atom of oxygen, from the atoms of oxygen. So this will now signify that copper, where there is 2 atoms as you can see, and oxygen where we've got 3 atoms. This will be the empirical formula of the compound. Thanks for attending today's lesson, and we request you to subscribe on our page and keep following for more that will be coming to educate you on more science subjects. Thank you.